And let me share my screen here. Hope you can see my screen. So this is NRP's training webpage. It's nrp.ai/training. Uh, as of the time of watching this training live, as it's still being conducted, you can see the sessions here, or the ones completed and the ones we have today, which are Advanced 1 and Advanced 2. And later on, this will show the recordings directly. You can see them here. There's a watch on YouTube link where you can click on it. It'll take you to the playlist, and there's the code and slides on the GitHub. And of course, the repository we're using, also sent it in chat. Please let me know if you're not able to see it. And you can see here, these are our two sessions today. So Advanced 1 and Advanced 2. The main topic we're going to be discussing today, and the most important topic, is NRP's GitLab integration. GitLab is a very, very important feature for everyone as an NRP user, as part of the community, to be able to use the Kubernetes cluster, the Nautilus Kubernetes cluster, more effectively, and to be able to do more interesting stuff, more elaborate stuff. This is extremely relevant if you're interested in hosting your own, say, JupyterHub instance. You can build your own images that have your own libraries. If you have your own user community, your own classroom, your own research lab, you can build your own images for JupyterHub, for Coder, for Kubernetes pods. And this is one of the GitLab CI/CD features and DevOps features. And of course, in the second part of the sessions today, we're going to be talking about advanced topics like using virtual machines, which is something that would enable us to run VMs, not just containers, for true virtualization, and something that would also enable us to, for example, run Windows on the cluster if we have a use case for that, and other edge use cases that we can discuss and hopefully have a more elaborate Q&A section. Just like always, you have to be part of a namespace or a group, whether you're watching this live or watching the recording, and you have to be part of a namespace or a group to be able to follow along and to be able to have a namespace where you're actually doing what so following what you're doing. And we can just get started. So the first thing we want to cover here is building in GitLab. So NRP's GitLab, and let me show you here. So this is what it looks like when you join in. And you need to have an account here. And first step here, to be able to use the single sign-on, you need to create an account first. So please, if you don't have an account on our GitLab, please go ahead and create one. And I'm going to be logging into mine. This is so once you're logged in, you can see your own personal Git. This is similar if you've used, so I'm just gonna sign into mine. Please go ahead and create an account and let me know if you face any issues in creating an account. And once you've logged in, you can see it's very similar to any GitLab that you've used before, including GitLab.com, which you're more than welcome to use. So we don't, just to make sure we're clear on this point, we don't enforce one repository control or version control system over another, but we simply provide GitLab to the community where you're running. This has many advantages. A, you're running things on the cluster. So when you're hosting images, they're still on the cluster. They're being pulled by the cluster. So it's significant performance a boost over using public registries, and you have one ecosystem. So your GitLab, we run GitLab for the cluster users. So integration between GitLab and your own namespace is better supported, better tested, and it's what it's there for and what we can provide support for and what we're admins of. So where we can have more space to support you better. And to jump straight into it, we created this test repository that you can follow along with. You can copy, you can use it as sort of a template for your own repository. I'm just going to send it in chat. So test repo, and I'm going to keep this live in case anybody who's watching the recording needs to use this. You're more than welcome to. And just like any repository, this can host files. One of GitLab's features is that I can let me sign in. I'm signed out. Here we go. And Here we go. So you can see there's an edit feature where you can just have a web IDE, and it's based off, you can see it's based off VS Code server. You can see it's very easy to use. And you can see here, you have a whole IDE inside of your browser, inside of GitLab, where you can modify things. And this is my repository. I'm free to add the files I want in here, and you can fork this. Since this is a public repository, you can fork it and create sort of a copy of it. So let me show you a fork. So I can call one test repo 2 and fork this project, and I'll have a copy of it that I can do things in. And of course, oh, it's conflicting because I'm doing it in the same namespace, but in general, you're more than welcome to fork this repository or copy the files. The files, we have two simple files. So a Docker file, and that's the main feature we want to show you today, is that how to build your own Docker images inside of GitLab. So we're not gonna dive deep into all GitLab features. You can read more about GitLab Community Edition features and see what NRP has to offer. But main two features we want to focus on: first is building images and using those images in Kubernetes. And second thing is integrating GitLab into my repository. So I can do things from the Kubernetes side inside of GitLab. So this Docker file, it's completely arbitrary. So I'm pulling from the Docker image I'm building on. And for example, I'm pulling the Python 3.11 image, and I'm installing something in it. For my case, I'm just installing GCC libfree type 6, and all of that is just to install matplotlib. And once I have my Docker file, this is the main file you need. So it's .gitlab-ci.yml. So this is one thing. So GitLab looks for this file in particular. The naming here is not arbitrary. It is .gitlab-ci.yml. And here I can specify in YAML syntax what I want the GitLab pipeline to do. So I'm telling it to use an image. This is a Docker image in itself that my pipeline runs, and I'm specifying what I want it to do. So this here, this is standard boilerplate for building a Docker container image, my bad. And you can copy and paste this. You don't have to change a single thing. You can just copy paste, and what it'll do is it's gonna look for a Docker file in your root of your repo, and it's gonna build based on the Docker file there. So this is of course referenced in our documentation on GitLab. So if you go to docs.nrp.ai and you type in GitLab, you'll see building in GitLab, and you can see I copied it and pasted it straight from documentation, and you're more than welcome to do so. And you can see it's the same YAML. And this will build my Docker file, my image from my Docker file. Now, let me show you what that looks like. I'm just going to add a change. So I just deleted an empty line just so you can see here. There's one uncommitted change that I can just simply commit and push to main. And you can see success, your changes have been committed and pushed. I can go to project. And you can see here, this is my repo. Now, the interesting thing here, you can see my latest commit where I just updated. And you can see here, I have this blue in progress icon. This means the pipeline is running. And I can click on it. You can see it has a job called a build and push job. If I click on this one, you'll see this is my job. Elapsed for 26 seconds, queued for 1 second before it started, and timeout is 1 hour. And this is gonna build my Docker image and push it to the GitLab container registry. So this in itself, this pipeline where it's running is in the Kubernetes cluster. So there is either a pod or a VM in the background that is actually building my image for me and executing whatever I put in the GitLab CI pipeline in my cluster, and then pushing the resulting image. Now, one thing to note here is that we've listed in documentation steps for like multi-arc builds if you're building ARM images, for example. So here by default, you're building your images for AMD 64, which is the most, as of time of making this video, of course, it's most of the cluster's nodes. But we do have a couple of ARM nodes. So if you're targeting ARM architecture and building images for your ARM architecture, you can build it within the pipeline if you specify, if you use BuildX with the multi-arc builds. So you can see here we're specifying Linux AMD 64 and Linux ARM 64. So of course, if you follow this approach, you'll only see one image built, but it's in a multi-arc image where you can actually pull the image and it'll pull for the correct architecture. And we have different tips here on how to optimize, how to get it faster. If you're building a bulky image that is multiple gigabytes, large size, and or has some intricate steps, and it takes more than 1 hour, you can the timeout is specified in the project. Let me show you actually. So settings and CI/CD. This is in my repository, so I have to be in my repository when I'm looking at settings and CI/CD. And you can see general pipelines. You can see timeout is 1 hour. I can, for example, make it 3 hours and can go back to my pipeline. You can see here, let me refresh. You can see it's unpacking, it's building. I'm just gonna let it do its thing. Uh, a few things to mention here is that when building your containers for your OS, dependencies, libraries, data, but libraries, dependencies, environments, but not data. So typically, whatever workflow you're running, you're going to have your data and you're going to have your software that you're using, your libraries, your Gondola environment, your pip installs, your software packages. All of that is fine within your container image, but baking data into your container image is not a very scalable solution. A, it makes the cluster slower for everybody in attempting to do so, and B, it does not scale well for you. So data naturally either lives in your persistent volume claims, or if you're able to use and comfortable with using S3, that's even more optimized. Uh, if not, then you can use PVCs without having to use S3. But data going into your container images, that will make them much heavier and will make pulling them significantly more tedious. So we're just going to wait for it to build while I show you our code here. So our code building in GitLab, you can see we provided the same YAML here, and we provided a sample Docker file. Again, this is purely for demonstrative purposes. You don't have to build a Python image. You can build more elaborate images, and this is a simple pod YAML. So what I'm going to do here is, and feel free to clone the repository as well. I'm going to do this while this builds. So I'm going to take my terminal and I'm just going to create training 30. And I'm just gonna create a pod here. I'm just gonna copy this over without changing anything. And you can see here, so up to this point, this is standard template YAML. It's creating a pod. I'm calling it my test pod. You can see I'm not specifying a namespace in my YAML, but I can do so if I want. I can set it either explicitly here. So just to show you, training test to delete later. And I'm naming my container. The container name is per my pod, so it's fine if you name all your it's fine if all of your pods have similar container names. Uh, and resources, I'm setting, of course, as a best practice, always please set both request and limit and try to make them equal to each other or very close to each other. This will also give you better performance if you're able to do so. And I'm using Python. I'm not going to request a lot of resources. You can see here my image. This is what we're building. So come back to that one. That's exporting to image. We'll just wait on it to build a little bit. And you can see here the command I'm running. If I don't specify anything, it'll run the default command in my Docker file. So in your Docker file, you can specify entry point and entry point command arguments, and those are what will run, or you can override them. And for us, I'm just going to run command Python with the arguments -c import matplotlib, and I'm just going to print that it imported without any issues. So if my Docker file is sane, this will run without any issues. If I have issues in my Docker file, this will be able to tell because matplotlib uh, did not uh, did not import correctly in Python screen data. Of course, what I mean here is by Docker file issues is that if it did not install matplotlib for the image correctly. If it has any syntactical issues or any semantical issues or issues that break, then the pipeline will fail and you will see a red X sign instead of a green check mark. So here you can either see a blue and running symbol or a green check mark or a red X, depending on whether or not it ran to completion or whether or not it ran successfully. But the Docker file and the container image building successfully, the point I'm trying to make is that if they build successfully, that does not mean you don't have to double check what's in your Docker file. So the pipeline building successfully, that does not validate whether or not I installed matplotlib correctly in my Docker file. That's dependent on whether or not I did it correctly in my Docker file. You can see here it pushed. Now here, my repo, you can see container registry. And of course, here you can see different repositories. You can have multiple repositories depending on how you define your GitLab-CI.yaml file. So here I'm pushing for AMD64, I'm pushing to my CI registry name, commit, checksum hash, and the image and latest tag. So that's what I'm building here. You'll see it's named after the repository. And whenever I build a new one, let me show you here once it loads. So this is checking the registry. It might take a minute or so. You can see here, this is the new one we built, latest, and it's 168 megabytes. Uh, it also builds at a checksum hash. So you can see it published 3 minutes ago. This is the same one as this one. You can check the digest. So it always adds a new hash, new tag, and pushes to latest. And of course, the logic for that is defined for me here. I can change it into something I don't, something different. Instead of latest, I can, since I'm doing it manually, I can call it manual build September 30. And if I run it using this YAML, it'll show manual build September 30. And of course, I ran the same pipeline just yesterday. So you can see an image here just yesterday for testing. And you can see when I ran it the first time, this was latest because it always updates what latest is. But since I ran it a second time, now this is latest. Of course, they're both identical, so it doesn't matter. But you can see here, there's a copy image path button, and I can click on it. And now I can go back to my pod. And for the image I'm using, I can just paste. And you can see we have a gitlab-registry.nrp-nautilus.io. So this link here is for the registry, not GitLab itself. GitLab is gitlab.nrp-nautilus.io. So if you visit this on the browser, it's not going to take you to GitLab. And this is the path for my container registry and the image I'm pulling. And I can save and quit. And I can run kube control apply -f pod.yaml. And since I specified the namespace explicitly, or if I have a default set to correct, I can not specify namespace. If I want to define a namespace, I can just type -n and call it the training test to delete later, for example. Of course, you need to have an actual namespace that you're able to run in. Training test to delete later is an actual namespace that we created simply for demonstrating. And once you run kube control apply dash f pod, get pods dash training test to delete later. You can see here my test pod is container creating and kube control describe pod. I test pod in my namespace. You can see here at the bottom, it's pulling the image from the registry. So far, so good. And you can see pulled, successfully pulled image. Now, if I describe, you can see completed. And I'm just gonna copy over the commands I ran so we can run them, but if you wanna test it out in a pod and you haven't built an image yet, feel free to copy the link to the image I built, or I just sent you the link, and get the cube control get pod or get pods, same thing, dash and namespace, whatever your namespace is. This gets you the namespace as spots, and of course you can describe. Let me copy the describe command. These are the commands I ran. And of course, since it completed, that means what completed means is that it ran to completion and it's not a container that sleeps or hangs around or runs something in the, there's no process to keep it running. All the processes exited successfully. So we can look at the logs by running kube control logs, my test pod. And you can see here, I don't have to say logs pod. I just say logs in the pod name dash m training test to delete later. And matplotlib imported correctly. Imported okay, my bad. Now, just to show you another advanced use case that you might run into is that you can have multiple containers in a pod. I'm just going to show you what that looks like. And I'm just going to call the other one just second. So the first one is called, they have to have unique names within the pod. So first one is called my test container, second one is called second. And I'm using the same image for the sake of demonstration. And I'm just going to change it to print message to matplotlib, imported okay on second container. And I'm going to be using the same resources and save and quit. And cube control, apply dash F. And my bad, I forgot. Oh, sorry. Let me just send you the command. So keep control apply is what we're doing. And of course, we're getting my test pod is invalid because pod updates may not update, add or remove containers. That's because we already have an existing pod that in this case is trying to modify it. So let's delete it first. So keep control delete my test pod to delete later. And here's the command to delete. Send it in chat. And now we try again. And cube control, get pods. Let's find our command here. Container creating, cube control describe. It's pulling the image. And of course, if you're running multiple workflows, so there are specific use cases where you want to have multiple containers per pod. One main one is when your container needs an, let me call it a secondary or supplemental container to help it, a helper container, if you need that as a use case. But in general, having multiple containers to sort of consolidate is not a good approach. It's better if you divide into individual pods in general. Of course, this goes without saying, but when you have multiple containers running within one pod, you can see here your pod. So let me look at the scheduler here. Successfully assigned the pod. So my test pod got assigned to a physical host, a server. So you can see here, even if you add multiple containers, they'll be on the same physical host node. So it's and scalability wise, if you compartmentalize into individual pods, if you're able to run one container per pod or the minimum number of containers per pod, that's the best approach. Of course, you're more than welcome to ask us if you need any help or if you want any advice. And of course, we're crash looping for some reason. Let's wait on it a little bit and let's look at logs. And if I can name my test container out of, okay. And of course, one thing I wanted to show you here is kube control logs. If I have multiple containers, the reason we're showing you is that you can specify the container with -c. So -c, I called one my test container. See, that one was happy, and I can look at second, and that one is happy too. So now I can see that it completed and all is well, and I can look at the individual container logs. And now just to show you what that looks like on K9s, let me just zoom in a little bit. Namespace training test to delete later, and it's showing this crash looping for some reason. I'm maybe not exiting right, but if I hit D for describe, you can see successful build image successfully. Oh, here we go. And if I hit L for logs, you can see in light blue, it says second. So this is logs from this container. It says matplotlib imported OK on second, and my test container, which is what I called the first. So if you remember, this is what I called them. So this is what I called them in my pod. And of course, if I have the pod running, I can hit enter and see here. So they're both crash looping. We'll take a look at that later, but I can see the two containers and I can hit enter on one and it'll show the logs for that specific container. Now, if we run back to GitLab, you can see here, you're more than welcome to test it. If you want to add something different, test something new. The next step we're going to be doing is, so we built our image. One thing I wanted to also show you is that in our documentation at the time of making this training, we provide the JupyterHub images that we build. So I'm just going to send you the link in chat. So JupyterHub images. So you can see here, we refer you to the repository where we build our images. And this is a public repository. So I'm just gonna open it in private browsing just to show you what it looks like for someone who is not logged in or is logged in as someone who's not on the cluster team. And from a user's perspective, you can see this is the repository. You can see the globe icon means it's public, and anybody can just go in and look at look at the pipelines and see what we do here because it's all open source. And B, look at the container registry. So you can see here, this is the Python PyTorch CUDA image that we use. And you can pull the exact same image that we use. So let me show you. This is JupyterHub. Let's say I start an image using this choice, NRP deep learning, and I start it. You can see these are the Kubernetes logs. You can see it's going to attach my volume. It shows you some Kubernetes details. So A, it's showing me the namespace name that JupyterHub runs in. B, it's showing me my pod name. So this is an actual Kubernetes pod that I can look at. It's a chat attaching my persistent volume claim. Now the next step is that it's going to pull my image, and at that point I'm going to know which image it's pulling that I'm normally used to using. For example, let's say that's the scenario you're used to a JupyterHub image and you want to elaborate on that specific image. You can correlate either from Jupyter, it shows you directly which image it's using, or from sorry, I lost it. or from the scientific images repository. So scientific images, you can see this is where I have the Python, MATLAB, RStudio, the base image, and the desktop one, which is the Sulkies one. And you can pull that image. So to show you, let's look at the container registry. So Python. Container registry. Python. And I can just use this in latest, for example, if I don't want to look at all the tags. And you can see now I have the link. So this is the link. Let me zoom in here. So this is the link, and I can use this. I can use this as an image in my pod, for example, or I can pull from this also. And here I can either assume latest or I can explicitly say colon latest. I'm just gonna send it in chat in case somebody wants to try it. And if I want to install something, so we can say add app installs here and add pip installs here. And now you have a skeleton of how you can actually take a JupyterHub image that we provide and add your own libraries onto it and add your own things onto it and customize it. This is extremely useful in cases of classrooms and in cases where you have a JupyterHub environment of your own. And it doesn't have to be the images we provide. So there's the Kubernetes, there's the, so you can see our pod actually started while we weren't looking at it. You can use our images that we provide. So the scientific images, one main motive to use them over other images is that we already pre-provide Jupyter AI inside of them, which you can see how to do it because it's all open source. So you can actually look at the Docker file, how we're installing Jupyter AI, and you can implement the same thing in your Docker files, or you can pull ours. You can pull any publicly available image and in any public registry. So you can pull directly from DockerHub. So it doesn't have to be pulling from GitLab. You can see when we pulled the Python image, this is coming from DockerHub. And one thing to point out here is that this repository is public. If I go to the repository settings and make it private, what's going to happen is that the image also will be private. Let's see where to do it here. Advanced. Sorry, I forgot where to change it to private, but oh, not bad. Back. Visibility. Here we go. I actually forgot where to change it to private. We'll do that later. But the main thing I wanted to show you is that if you create a private repo, it shows up. Oh, here we go. General repository. And if you make it a private repo, the image itself becomes private. And of course, if you want to pull a private image, you can do that. So it doesn't have to be that if you're building an image, it needs to be public to the entire cluster on GitLab or the entire GitLab user community on the cluster. But you can make a private repo. That is one thing you can make. And once it builds the container registry, that will also be public. And actually, we show you here. So this is building in GitLab. If you build it as private, we show you the steps on how to get your credentials. So from the repository, you can get your access tokens. So let me show you here. So I'm in my repository, settings, access tokens. And if you add a new access token, let me call it my token. I do all the steps. And now it'll give me a token and I can place that token inside the Kubernetes secret. So let me show you what that looks like. So this is our VS Code. This is our command. And of course it's referred to here. Let me send it in chat. And what I'm doing here is I'm creating a secret called docker-registry. Secret called registry credential, red. And the server it's using is gitlab.registry-registry.nrp-nodes.io. And in our case, this will look like this. So it's gitlab-registry. .nrp-mods.io / the group name / the repo name, and the username is gitlab dash what the token is. So it'll show you the token name, and password is the token. So you see the token name and you'll see the actual token. So the access token. Once you create the secret, let me show you. So let me show you here. See if we have one here. So I don't have one here, but these are my secrets. You can see you can have a similar one here. And if your image is private, just creating the secret. And the next part is adding this image pull secrets inside of your spec. So this makes it use the secret, which we call regcred, and this will automatically allow it in your own namespace to pull private images. Of course, this is public to the namespace users. So if you if you have other users in your namespace, they'll be able to use the secret and they'll be able to pull the images. So it's as a namespace admin, it's up to you of the scope of access. So let's say you're building an image that is private to your namespace. You can add the secret to your namespace, or if you're building an image that is private to you, you can create a namespace of your own where that namespace has the image. Of course, the authentication here between GitLab. So GitLab on its own and your Kubernetes namespace on its own, they don't have any association that you're the same person or they're tied in any way. They're both running on the cluster, yes, but how they're tied is either if you're pulling a private repo, if you're pulling an image from a private repo, you need to provide the credentials from access tokens. Or if you're letting GitLab perform actions in your namespace, this is where you also need to authenticate, and that's what we're going to show you in the next part. I'm just going to pause here and see if anybody has any questions, and just simply pause here and see if anybody's caught up. If everybody's caught up, if everybody's on the same page, if the pace isn't going too fast. So if you have any questions, please feel free to send in Q&A. If you have any issues, please feel free to share in Q&A. Or if you want to unmute, also please feel free to, I think you have to raise your hand in the webinar session and I have to click allow from my end. So please feel free to do so. And so far, has anybody had any success with building their own image and pulling it? Also, if you'd like to share, please feel free to do so. All right, so uh, we're gonna do things slightly differently. I'm just gonna give everybody a 5 to 10 minute break. If you want to, between the two sessions, if you want to take a little break, I don't want it to become a little overwhelming. Please feel free to leave. Right now it's 1:45. At 1:55. Oh, sorry, I'm on Eastern time. So we're doing at 1:55 Eastern. That's 10:55 Pacific. So I'll pause the recording here. Right, welcome back everyone. Hope everyone had a good break. Now what we're going to talk about here is how to connect your GitLab repository to your Kubernetes namespace. So your repository in your CI/CD pipelines can perform actions inside of your namespace. So this is my repository here. You can see, as we mentioned, you can add it to the web IDE, and you can see here from operate, it can connect to Kubernetes clusters. So in my repository operate Kubernetes clusters, I can connect my repository to my namespace. And what I'm going to do is, if you're using NRP's GitLab, as of the time of making this video, and you can also read it in documentation, so the best option is to use connect to a cluster certificate deprecated. And that's because it's the simpler approach towards running within NRP and connecting within NRP. Of course, the documentation for that, I'm just gonna send it here in chat. Here's the full documentation page. So please feel free to check that out. And this is what we're going to be doing here. So we're going to be connecting to our cluster. Now our cluster is called Nautilus. Our environment scope, we're not gonna, or we can create, let me just call it, for example, NRP and API URL. API URL, you can see as of the time of making this video, it's consistent across the cluster and static, but here's the API URL, see it in the doc page, and I'll send it in chat. So cluster name is Nautilus and API URL is here. CA certificate, we're gonna get that, and the service token, we're gonna get that. So the way to do so is you can see here in the doc page as well. What we're gonna do is create a service account in our namespace, and we're gonna be using that. So here's how to do so. You can see the code both in the doc page and you can see it in the create the service account. So it's just kube control, create service account, GitLab in your namespace. So let me show you here. The namespace I'm going to be using is our training test to delete later. And let me show you in K9S. This is our namespace secret. Let me just clean up a little bit. And secrets. You can see here I have 4 secrets, and now I'm going to create kube control, create service account. Sorry, service account, not secret. I have 2 service accounts, and I'm going to create a new one called GitLab in my namespace. You can see it created the a service account for me, and I can also run kube control get service account in my namespace. And let me send the commands in chat. And once I have the service account, what I'm going to do is, so service account is simply put in an oversimplified fashion, it's a way of letting, it's a way of giving privileges to let's say something, a way of giving privileges within your namespace to something. And what that something is something that uses the service account. And what privileges it gets is what from it is called a Kubernetes role. So you have your Kubernetes role that says you can do these things, but not these things within the namespace. You can create pods, or you can just take a look at pods. This is the role. And the U in this case is the service account itself, which, so for example, in our use case, we'll let GitLab use the service account. The service account can do and can't do based on the role. And the glue that sticks it all together is what is called the role binding. So you can see here what we're gonna do here in the next step is, so we have our service account created. Second thing is the role binding, which we're gonna copy here and paste. So role binding.yaml. And just to take a look at it here, what we're going to be doing is creating a role binding. And the name of the role binding is GitLab. And we're going to specify the namespace. Again, if you don't specify this here explicitly, you need to add the -n, or it'll create in the default namespace that you have. So you can see this is my YAML for my role binding. It's called GitLab in my namespace. And the role it's using is the cluster role admin. So this is a predefined role that is there cluster-wide for the entire cluster that is called admin. What this tells it is that we're creating a role binding that gives the privileges of the admin role to the service account GitLab that is in the namespace training. That's to delete later. So we have all the pieces we need. So the first piece is the role cluster, which is the cluster role admin. This tells me I can basically do anything an admin can in their namespace. And I'm gonna add this role to the service account GitLab, and the glue that adds the privileges to the service account is the role binding. And now whatever or whoever gets access to the service account can do admin stuff in my namespace. Now the step after that is giving GitLab access to that role binding and access to that service account. So you can see this is its own YAML. And this is its own YAML. And I can do that. You can add multiple YAML schemas inside the same file by adding the 3 dashes. And you can, for example, add a pod or add something that is in a completely separate namespace or completely unrelated. It's a way of sort of consolidating YAML schemas in one file. And the other YAML is the secret. So this secret, what it does is I'm going to call it GitLab-secret, again in the same namespace. Now, when I apply this, what it's going to do is that it's going to create a token. You can think of it like simply like an API token. And whoever gets access to that token gets access to the service account. So just to briefly go over the steps, I have the service account called it GitLab. That service account has access to the admin role, and what says it has admin access to the admin role is the role binding. And I'm gonna create the secret. The secret is what holds the token that I'm gonna use, and Kubernetes is gonna generate that for me. So whatever is inside the secret, that needs to be kept safe. Whoever gets access to this can perform actions in your namespace, so you need to secure it and make sure not to share it with anyone outside of your namespace. And of course, once I create all of this, I'm going to save and cube control apply -f role binding. You can see it created the role binding and it created the secret. So I'm going to write cube control get role binding -n claiming best to delete later. You can see 15 seconds ago created the role binding called GitLab that has the role cluster role admin. And of course, you control get service account training has to delete later. You can see my GitLab service account. Of course, you can say SA, just you can abbreviate it into SA and that will also work. Let me just send them here. And now we go back. So now we can fill out the rest of the pieces. Now what we need is the secret. So you can see here, here's the command. We added it in our documentation, pasting it here. So you can see you have the secret and then you're gonna save it into a YAML. So when I say let me show you. So kube control get secret, GitLab, and of course once the can see here, so training test to delete later. Oh, GitLab-secret, my bad. So I called the secret GitLab-secret. You can see here I created it. Now I can add -o, sorry, -o and YAML, and this will give me the entire YAML. And of course, you can see the secret here. It's exposed. So this means if you're watching this live, this token is now exposed to you publicly, which means that naturally, from a security perspective, I have to delete it later. But it's fine if you're watching this and gain access to the training namespace, and even use this if you want to test it out inside the namespace. But you can see this is our complete YAML. Of course, if I want to output it, this is a unit command, but I can just add the greater than sign and just say secret.yaml. And now if I hit ls, you can see it saved hit the secret.yaml. Of course, in K9s, I can just type secret, and I can just hit D for describe, and I can see it here, or Y for YAML and see it here. Now these are the things I need. So I need the CA certificate and I need the token. So CA certificate, I'm gonna copy over all of this. And I'm gonna echo it inside of two quotation marks and pass it in pipe to base 64-D, which is short for decode. So this is our input. So I'm echoing this. So echo means print, just it's printing the token, the certificate, sorry, in pipe. So it's being passed to base 64-D, which is the same thing as saying base 64-D. And, oh, sorry. And giving it the output. And once I do this, I made a mess. My bad, here we go. Sorry. This is our certificate. We're gonna copy it and paste it. And this is our GitLab repo. See a certificate here. Now the service token, the service account token. So we have our secret. And let me just show you here. Once I printed with the entire YAML, I can now copy all of this. And let me zoom out to show you the whole thing. So we're not cutting it in the middle. And same thing, echo, quotation marks, pipe, base 64-D. And this is my service account token. I can just paste it here. Now here are the important things. So you can say this is an RBAC. RBAC is a role-based access control. It is an RBAC. You can see them here. So it is a role-based access control cluster. It's not a GitLab managed cluster. So it's not, GitLab's not going to be managing namespaces and service accounts. It's going to be acting on the namespace level. Namespace per environment, you can keep that checked and enter the namespace environment. So if here, as a best practice to make things simplified, you can enter the namespace name as can enter the namespace name in your project namespace prefix. So for us, that's training test to delete later. Just to briefly go over it again, cluster is Nautilus, environment scope, you can name it whatever you want. API URL, this is both in our documentation and in your config file that is in your cube directory. You'll see it there. And CA certificate is from the service account, and the service token is from the service account. They need it to be decoded with base 64, and then you can add Kubernetes cluster. And now see it's a project cluster. I can go back to the repository, and now for the fun stuff. Now I can, let's say, as a cool test, let's just add So let me peek into the 9 directory and peek into the code and the Ubuntu VM. Just copy the YAML over and paste it here, for example. So this is my repository. I'm just going to create a vm.yaml and paste it here. And simply adding the file, this is not going to change anything. It still builds a new Docker container and pushes it. Now I want to try something different, so I'm just going to just call this backup. I'm going to add another new one. And in here, I'm going to specify what I wanted to do. And now my repository is linked to my Kubernetes namespace. So my pipeline can actually perform action within my namespace, which is what I'm going to do. So I'm just going to copy over a pipeline here. So this is what we have. So we don't need tax dog parent. We don't need a before script. So stages, let me call the stage deploy since I can name that, and hopefully this won't fail on us on the get-go. This is sort of unrehearsed, so let's see how it goes. And this is my stage deploy that we're testing here. And of course, oh, so this is the job. So it's the deploy, let me call it deploy jobs in stage deploy. And the script, so this is an actual Docker image called Docker on the commit git on the tag git. What we're going to be using here is an image that so in the runner we can use whatever image we want. I can say Ubuntu 2404, for example. And then it's the pipeline itself, whatever the script is, it's going to be running in Ubuntu. So if I wanted to do Kubernetes stuff, naturally, how we do it as users, we use kube control. Similarly, the pipeline will be using either kube control or Helm or other Kubernetes commands. Now, if I'm using an Ubuntu image, I have to install kube control and configure all of that my own, or I can use an image that already has kube control. So there are the Bitnami legacy images, for example, and they already have kube control. I'm just going to give you one example that we use internally just to show you as an example. I can specify this image. I'm going to send it in chat. Of course, if you're not watching this live, just make sure you have a valid image from JupyterHub because commits and registries and all, they change with time. So make sure you have an image that has kube control and is available as of the time of you running this experiment. And of course, we're seeding into the project directory and we can simply run kube control -f and the vm.yaml. And hopefully this won't crash on us. Let's test it out. I'm committing, trying out pipeline and committing and pushing to main. And go to project and let's take a look. You can see here, well, you saw the pause sign, that means it's queued because the runners on the back end, they're pods and VMs that are actually running on the cluster. So at peak times, you might see them queue things up and not send them instantly. So that's perfectly natural in terms of from a scheduling perspective. But as you can see here, we do have the capacity, so we're running things here. And you can see here we ran into our first error. So you can see namespace. That's where we're running things. We're not specifying our namespace. So you can either specify an environment or you can say to delete later, which is perfectly fine. But you can see here, let's look at our error message. You can see our virtual machine that is running the runner, which is using the service account. Oh, let me see here. Let's see. I think we forgot the environment. So we didn't use the environment we specified. So let's run back and test it out again. So environment is, I think we call it arbitrary, just to show that it's arbitrary, but let me check. So it's an operate and Kubernetes clusters. And yeah, we called it arbitrary. So this is the environment scope that actually lets it use the service account that we specified and the service account that we specified and the cluster information. And now let's try it. Otherwise, it uses the runner's default, which by default, the runners are not allowed to access users' namespaces. And now let's test it out. And you can see your job is creating a deployment to arbitrary. That's our environment using cluster Nautilus and namespace training test delete later. And you can see here, at least for us here, error validating data, failed to download OpenAI. And of course, at this point, it's better, it's progressing, and now we can just we can progress to debug whatever issues that we have. And let me try something simpler. So back to 8. Let's try the pod we tried first. And our pipeline, and let's see here. And here we go. So let's see if we run to validate, we can turn off validation, but let's try this with the pod YAML. If we run into issues again, we'll just switch off validation. And you can see here, so this is our namespace. And you can see the job itself got named after what we called it. So it's deploy-job, which is specified here. So you can have multi-stage, multi-job builds. And here we go. Right, let's turn off validation. And hopefully this won't have the demo effect and not work on the fly. So fingers crossed. And so let's wait on it. All right, the server has asked the client to provide credentials. All right, let me see what's going on here. I think we messed something up. Let me see here. Okay, environment. All right, I have to look at this. Let me just jump to the next part so I'm not skimming on the VM part and run back to this and try to debug it together. So the VM part, just to show you real quick. So you can see here in the second advanced part, we'll just show you a simple VM and then run back to try and debug this. So send it in chat here. So you can see here the code for a simple Ubuntu VM. And what we're trying to do here is very similar to what we have in docs. So you can see another version in documentation where you can see here, and you can just copy and paste this inside of your YAML file. So let me show you. So vim ubuntu-vm-yaml, and copy and paste this, and it'll create a VM for you that is going to populate your SSH keys from pub-keys. So you can see here, we show you how to create the keys in here. So let me just show you real quick. So kube control get secrets. Let's say, so this is my namespace, for example. You can see I have, so this is my own personal namespace. I have a pub keys secret. Similarly, for the namespace we're trying things in, so we can say pub-keys.yaml, and we can just copy and paste this. And I can paste in my key here. And of course, the way, so this is Ubuntu virtualization. And I can paste in my key here, and the way I get the encoded key is by, so let's say, so normally you'll have your SSH key in your .ssh directory, and then you'll have the key name and the key name.pub, which is the public part. And here you only need the public part. The private part is what should not be shared even on the cluster. So you're getting your public one, the public part of your key, and once you run cat, it'll print it. This is both for Unix systems, so on Mac, on Linux, and you get the public one, and you can echo it. So my public key, and similarly pipe base 64, and this is the encoded one. So you'll copy the encoded version, not the original one, and you'll paste it in your pub keys. And let me show you here. So you'll paste it, and you run cube, control apply, -f, pub keys -n, training test to delete later. So here we go. This is the this is the cube apply command, and this is how we encode. And this is the YAML. Let me just copy it here. Of course, don't forget to set your namespace. Otherwise, if you don't have a default one that is set correctly, otherwise it's going to use a namespace actually called default, which users by default don't have access to. So you'll get issues trying to create the secret. Once you have the secret, you can apply the YAML. And let's take a look at the YAML here. So vim VM ubuntu-vm. So let's take a look here. Similar to how we had kind pod, we can have kind virtual machine. And metadata, I can call the virtual machine whatever I want. So my virtual machine. And spec running false. This means from the get-go it's not running, but I can set it to true, and this will start it as running. And in my template access credentials, I'm adding my SSH key. And you can see I'm adding the key from pub-keys. And similarly, if I need to set the namespace explicitly, I can add it here. And you can see here, domain, I'm adding 8 CPU cores. And of course, I can hear let's show you here. So domain, CPU core, 8 CPU cores. Attached graphics device is set to true. So this will add a virtual graphics device, which means I can use VNC and I can see the desktop environment. And attach auto attach serial console also attaches the serial console. So if we're running a Linux VM, we're able to sort of SSH into it, run VNC on it, access its console without doing extra stuff. Disks, we're defining a virt IO disk, which is something that which is the wave virtualization of the input and output in the KubeVirt. So KubeVirt, this is all running in KubeVirt, and KubeVirt allows us to run native virtual machines that are running on the host server. So the server is running a VM, and the VM has the server, the node, the physical server is running a VM, and we have access to the VM through Kubernetes. That's what KubeVirt provides. And of course, in that VM, I can attach PVCs and I can attach all kinds of input and output, and that relies on VirtIO. You can see here we're attaching 3 disks. So one of them is called hard drive, one of them is called VirtIO container disk, and one of them is called cloud init, and they're all relying on VirtIO. And we're gonna see a little in a second what they do, and we're specifying the type of machine. These are all KubeVirt parameters that you can read more on, and virtualization parameters that you can read more on, resource limits and requests for the both the VM and the pods that are accessing the VM. You can see here volumes. Here we go. So disks are using these volumes, and let's define the volumes here. So you know how we had volume mounts and volumes in pods. This is very similar. So we have empty disk hard drive, 16 gigs. This is ephemeral storage. This is local scratch from the underlying host server, host node. So this, when we say hard drive, it's using this, and the VirtIO container disk is running from this image. So we're pulling a container disk image that has Ubuntu 2204, and we're mounting that as well. Last thing, we're mounting a cloud init config drive. So we're mounting one drive as a cloud init configuration, and you can read more about cloud init if you're not familiar with the cloud inits on Linux or in general. But basically, this sets up. You can sort of think of it as startup configuration for having our VM work from the get-go. So what we're gonna do is we're gonna save this and apply it. So cube control Ubuntu-VM. And since I'm not specifying a namespace, I'm just gonna create one in training test to delete later. And I'm gonna create one in my own personal namespace as well. And you can see cube control get virtual machine dash and training test to delete later. And you can see my virtual machine status starting. And cube control get VMI. Oh, sorry. Cube. Actually, let me send it in chat. So virtual machine and cube control get VMI. And test to delete later. And this is what we call a virtual machine instance. So this is the running instance of the virtual machine. And you can see here, status is running. And in K9S, I can also go to training test to delete later. You can see I have the VM here. Just here we go. My bad. Here we go. This is our virtual machine, and this is our pod. Sorry, this is if you type in virtual machine, you'll see the virtual machine. If you type in virtual machine instance, you'll see the instance. And you can see there is a, let me call it helper pod that is virt dash launcher dash whatever I call my VM dash SFX. And this runs containers that help KubeVirt in provisioning the VM and provide access through Kubernetes. And now I have my VM up and running. What we can do is there's this command line called tool called virt control. And let me send this in chat. So virt control, very similar to how we installed the other components. If you're on Linux and Unix-based systems like actually, if you're on Linux, the easiest way is to just copy and paste these 2 commands. So you can see here, it's getting the version from you can see here, it's getting the version from their releases. Now, if I echo version, you can see it saved it as an environment variable. So you can see the most recent client version is 1.6.2, and the wget command just downloads it. And looks like it's not available. Let's go back to their control on GitHub. So this is their repository. Let's look at releases and vert control. So if I'm on Linux, this is my link. Just gonna paste it in chat. Of course, this is for AMD, not ARM. This is for ARM if you're using an ARM machine. And similarly for Windows, you can copy and paste it here. Now on Windows, just like Cube Control, Cube Login, if you download it for Windows, it needs to be called Cube Control without the additives. So just kubecontrol.exe, and it needs to be placed in your path environment variable directories. So you know how you placed, if you're on Windows, you placed Cube Control and Cube Login in specific directory, and you let your system peek into that directory to see your executables. You need to place it in a similar directory for this one as well. And your system will be able to see it. You'll be able to run vert control or vertcontrol.exe and see it. Or you can just cd into the directory that has vert control and run from there. If you're on Mac, if you're using an ARM machine, so Mac, ARM, and Mac, Intel AMD. So if you're interested in running VMs, this is vert control. It's a command line tool that lets us allows it makes our life easier basically with plenty of handful tools. So we can write wget, and for me, for example, I'm gonna copy the one from my machine, and you can see it's downloading vert control -v162 Darwin AMD. It's in here, and I can just change the mod to make it an executable. So you can see the command is just wget, and the link goes in here, and then change mod-x file name, and now it's an executable. I can just run vert control. You can see it's showing me the options. That means it's running. And now this talks to Kubernetes directly. So similar to how kube control looks at my config file, authenticates with the cluster and so on, I can just run vert control and then say dash, I think it was list or vert control. Here we go. Let's look at the options. Vert control, different options. The ones we're interested in are VNC. So sorry, here we go. There's no list option. For list, we can just run kube control VMI, kube control get VMI. So currently vert control doesn't have any list option. And I'm gonna send it in chat. And for access, since it's running, I can run vert control, and I can say VNC and my virtual machine. And a namespace training test to delete later. As you can see, this is directly from my machine, and I'm pulling a Docker container image that is a Ubuntu console image. You can still do more elaborate things. You can mount ISO files as what we call data volumes, and you can install Ubuntu desktop if for part of the reason you want to use a VM is something related to graphics, you can have a full desktop environment inside of your VMC. And you can also do, instead of VNC, you can do SSH. So let's go back. Instead of VNC, I'm gonna type in SSH. Now, a few things to note here and a few things to mention. SSH from the get-go, you can see here. Uh, this is a warning. This is not, this is a warning, but we can still use a different version, probably. If it's not too off, we can still use it. But the first thing you need to do is specify VMI slash. So virtual machine instance / my virtual machine. I can type in yes. And second thing here is exit status 255. So the second thing is I need to specify user, which is -L. If you're not sure, run --help. And you can see where is it? -L specifies the username. So for me, my username here is MFSADA, so it doesn't use my system default. You need to specify -L and let's say Ubuntu. And you can see it'll also fail. And the reason, and for some of you, it might fail if you're following this step by step. And the reason is if you have your SSH key password protected, that might fail if you don't add the SSH key again, because Vert control in talking to SSH, it has no way of prompting you for your SSH password. So you have to run SSH-add, then whatever SSH key you're using, and then it's going to prompt you for the password, for example. And then you can run this, and in my case, it'll fail as well. And that is because if you remember in our namespace, so for me, when I created it, I added a dummy value to my namespace secret. So you can see this is my secret. If I get the -o YAML, you can see here, this is a dummy value. It's not an actual key that I have on my system. Now I can just send you the commands in chat if you're trying to do this, trying to follow along. So you can see the commands here. Now, if you're on Mac or on Windows or on Linux or on any OS that you're using, you need to have a VNC viewer client that you're able to that you have installed on your system, so you're able to follow along. Real VNC is one of them, Tiger VNC is one of them, and whatever client or VNC client you're comfortable with, you can use that client. SSH does not need anything extra. You can just SSH, and just going to show you here. Hopefully you won't disappoint us. So in my own namespace, I created another one just so we can have one that is running. You can see here my VM running. This is the one that we created, my virtual machine. So it's the same one, but in that one, I actually do have my, let me show you. So in this namespace, in my own namespace, I do have an actual key that does work. So that's what we're gonna test here, and hopefully won't disappoint us this time. And we're gonna, same thing, VMI / the VMI name, and -n the namespace and -l Ubuntu. And typo, sorry about that. Let's add yes. And you can see I'm inside my VM using SSH. And of course, I can, let me run super user. I don't have a password. I have super user access. And let me run password. And I'm going to set it as 123, 12. Oh, jump the gun. Let's try it again. Current password. Oh, there is no current password. So let me just exit this and run super user password. And new password is 123, 123. And one key thing here that we see a lot of VM users run into is that the container image that you're using for Ubuntu does not specify a default password. So you can either set an explicit one with cloud init config, and the KubeVirt documentations have plenty of examples for that, or you can use SSH into the VM. Now that I set a password, I can exit this, for example, and I can run virt control VNC. And let me VNC my virtual machine and I'm running this in my namespace, so I can run. You can see here the default username is Ubuntu and password is 123, and I'm in. Oh, that was unexpected. Okay, let's run back, try to see what we did wrong. And SSH again. And oh my bad, here we go. I see what happened now. So I changed the super user password, but not the, here we go. So if I remember correctly, I might be missing the syntax. Here we go. New password. Let's try it now. And VNC, Ubuntu, 123, and we're in. Now we can do super user. We have sudo operations or sudo operations, and we have connectivity just like we have in a pod from the underlying node, and we can do plenty of the things that we can do in pods and attach PVCs and do advanced workflows. We can do the same in VMs. And the main thing and advantage that we'd like to highlight in using a VM is that your containers themselves don't have access to Docker. So you can pull Docker images inside of your container, inside of your pod, sorry, and run containers inside of your pod, but Kubernetes will be doing that behind the scenes for you. But if you have Docker Compose profiles, for example, or building an image in Docker and you actually want the Docker daemon and the Docker command to work in your OS or VM or container, whatever you're running, so your environment needs to run the Docker command and Docker daemon, you can do that within your VM. Of course, you're gonna apt install if you're running Ubuntu. And if I remember, that was docker.io, and if I'm not mistaken, and you can apt install whatever you want. So if you apt install Ubuntu-desktop, this should install both. And if you add in -y, this all right, this is because I'm going a little overboard. This is purely for demonstrative purposes, but you can also there's no constraint in storage. You can add persistent storage mounted at / or mounted at the root directory. So you have every single thing you do in virtualization is persistent, and every single thing you do in your OS is persistent. And you can do all of that stuff that we're gonna do. But let me just show you Docker without going overboard with the space. And this would allow us to run Docker within our VM. And here we go. So Docker by default is not, here we go, Docker run, hello world. Now let me see, improve Docker. Oh, let's see. I think this might need a reboot, but either way, this is a VM. You can reboot it. Okay, let's see if it's all. Oh, we're seeing errors. That's perfectly fine. It's a disk full. We can mount more storage. But in general, the thing I wanted to show you is that you can reboot your VM. So if this reboots, you see VNC might crash or might show you a lingering black screen for a while. But in the end, you'll see a pop-up screen, a similar screen to how you see, and you'll see you have your own virtualized BIOS. So you do have a BIOS screen, you can access it, you can change the boot orders, you can have multiple boot devices, and you have your own dedicated VM that is running within Kubernetes scheduling. And of course, it being scheduling, if you request CPU cores, memory, whatever resources, you can do advanced stuff like request huge pages if you're doing like hardcore lower level system experiments. And this is all Kubernetes scheduled. there won't be any overlap, there won't be any collision between pods and VMs. Of course, the caveat here is if you want to use GPUs with VMs, please contact us as cluster operations team and we can help you in showing you how everything works. But in general, this is how you run virtualization. The other thing is Windows. So let me show you the documentation for Windows. And of course, we added a copy here. Now, of course, running Windows on it by itself is something that requires a lot of time. So we're just going to show you the how here. So this is where we link it here in our docs and our tutorial. So with Windows, one thing you can see here is that we're creating something called a data volume. So let me call it my data volume and a namespace training test to delete later. And this is a URL. And of course, we do not provide a link to download Windows from. You have to agree to Microsoft's terms and conditions and so on, and have your own URL that you can pull Windows from, or whatever ISO file or archive that you have. And just to give you a brief example, uh, let me look for it. I don't have it off the top of my head, but for example, for Ubuntu, you can have public links. Actually, let me. So there we go. Here we go. Sorry, my bad. Let me just do this real quick. Here's a link, for example, and you can, this is a public link that you're more than welcome to share. And it has Ubuntu desktop, for example. I just want to provide this as an example for a URL that has an ISO. And of course, storage needs to fit it. This is for the installer. So in Windows, generally, this is the Windows ISO, so where you install it from. And the storage class name is the storage class you're using, just like how you do with normal PVCs they use with Kubernetes, and Linstore is faster than block devices, but we please feel free to please make sure you sort of clean up and housekeep after installing, and you can after installing you can delete the data volume, but this is just to show you a example. So kube control, apply the data volume, and let me see if I added the namespace. I did add the namespace, so let's look at the namespace now. And you can see here I have a new pod that is pending. It's called importer-prime. And this importer is what's going to pull the ISO, put it in my data volume, and basically put it in my PVC. I'm just going to let it do its thing in the background while I show you the rest of the YAML. And of course here, after you created your data volume, you create your own PVC. So this is a persistent volume claim that of course is going to be accessed purely by the VM, so one pod at a time, so you can have it be RBD, so rook ceph block, or wherever you if you're using a different zone, so like a rook dash ceph dash block east or central, without specifying it's west. And I'm calling it WinHD. It's read write once, and it's 50 gigs. Of course, this is persistent volume, so it's depending on how much volume you want. And the Windows VM is slightly different from how we define the Ubuntu one. So please make sure. So for example, secure boot is enabled. Please make sure that the one thing here, so there's a USB device added. This is added there by design because this makes mouse tracking faster. So please use this as the boilerplate that we provide for if you're using virtualization with Windows. to get the most performance out of it. That we tested and tried to optimize as much as we can. For Ubuntu, let me show you here. So similar to how we did this, you can do the same thing with Ubuntu, where see how we have WinHD, you can do the same with your Ubuntu VM. And this is our Ubuntu VM to show you the difference here. So we're mounting our container and we're mounting 16 gigabytes of scratch storage, but you can also create a persistent volume claim and use that as well. And just gonna pause here and see if there's any questions, but this is basically how you install Windows. And actually before questions, let me show you here. So you can hit L for logs and you can see this is the percentage. So this will populate our data volume in our PVC with the ISO archiver and the installer, and we can boot from it. So once your virtual machine starts, and you can see here, so Ubuntu-VM, so spec running, you can specify as false, and you can run vert control and stop and start. Those both work. So stop my virtual machine. This stops my virtual machine. And it's scheduled to stop, and you can look here. So this is my namespace, the one that I stopped. It's terminating the pod and it's gonna stop the virtual machine. And start similarly starts it. There's restart. And once I started, so it stopped. Once I started, my schedule to start, you can see here. So vert control, oh sorry, not vert control. So VNC from the get-go, it's gonna say the virtual machine instance is not running yet. So I'm gonna give it some time. But as soon as it starts, I might catch the boot options if I'm not too late. If I'm too late, I can restart and I can catch the startup screen and then hit delete or F2. I forgot which combination it was, but which key it was, but you can enter BIOS and boot orders, or you can specify them in YAML as well. So you can see here, this is the Windows one. We have one we calling CD-ROM ISO. So you can see this is using the data volume that we're populating. And let me just check on this. So this is using the data volume we're populating, and we're setting its boot order as 2. And this is using what we're calling hard drive. So hard drive maps the PVC that we're starting. So just a normal PVC, we call it WinHD, and it's set for boot order 1. And last one is VirtIO container disk, and it's using this image. This basically is to provide drivers for Windows, so it's another disk that allows us to install drivers for Windows. So for Windows, it's better if it's there in general. And we can do the same thing with Ubuntu, where we can just use disks at boot order. Then we'll see the ISO second, the hard drive, which is a PVC first, and that will allow us to install from the ISO and boot from the installed OS once it's installed. And you can see my data volume, it's still pending in PVC, but if you look at data volume, import in progress, you can see here, this is our data volume, 98.6. Since my importer pod is no longer there, I can anticipate success. You can see here succeeded 100%, and you can see my PVC is finally populated. It's 10 gigs. And I can do the same with Ubuntu server, and I can do the same with persistent storage and so on. And I think I'm gonna stop here. First thing I'm gonna do is I'm gonna stop the recording.